Okay, I was looking over the Ready Set Go for 4.4, and this is an amazing homework assignment, and it's really taking you to some good places that are very important for your future in mathematics. So I thought I would do a video where we're going to go over every one of these problems very carefully to really help you all out. So when you've done this homework, I hope you'll look at this video and check your work and just compare and see how you're doing and where you might have some questions. And if you do have questions, never hesitate. You may email me at any time you like. All right, so for the ready, write an equation that describes the story, then answer the question asked by the story. So essentially we have story problems here. So number one, Virginia's painting service charges $10 per job and 20 cents per square foot. Okay, if Virginia earned $50 for painting one job, how many square feet did she paint at the job? So what we want to do as a mathematician is take this sentence and translate it to algebra. So let's think about it. And they asked us to write an equation, so let's start with an equal sign. Now, let's try to translate Virginia's painting service charges $10 per job and 20 cents per square foot. Now, the way they wrote that may be kind of confusing right there, but you need to think about this in the real world context. 20 cents per square foot. So I would make my independent variable x the number of square feet that Virginia paints. So that 20 cents per square foot would be like a 0.2x. Or you could go 0.20x if you want, all right? And then the job, she charges $10 just for the job. So we're going to add $10 to that. So equals 0.20x plus 10. All right, that's a great expression for the right-hand side of our equation. Now, if Virginia earned $50 for painting one job, so this, she's going to earn 50. So let's put the 50 over here on the left. And that's the first part. We've written an equation. Then answer the question asked by the story. So if we solve this equation, which is pretty amazing, you guys are to the point where you can take sentences like this and translate to algebra and then solve the algebraic equation to answer a question. That's what math's all about. So we need to isolate this x right here. So do you see that plus 10? Why don't we begin by subtracting 10 from both sides? Equals, and on the left you have 50 minus 10 is 40, and on the right you have 0.20x, and you see the plus 10 and the minus 10 just cancel each other out. So now we have only one more step. We have to undo multiplication by 0.20. So what undoes multiplication? Division. So let's divide both sides by 0.20. So x equals, now on the right, do you see that those 0.20s would just cancel out, leaving the x, and x equals, and over here, let's just go 40 divided by 0.2. And you guys, I'm going to do that on a calculator. So I'm going to get my calculator out and go, and please punch this out with me. 40 divided by, I hit times, let me change that. 40 divided by 0.2. And I'm getting 200. So it looks to me like Virginia painted 200 square feet to do this job and make $50. And that is algebra, you guys. All right, let's take a look at number 2. Renting the ice skating rink for a party costs $200 plus $4 per person. Now, my equation, and now I'm going to take this, $4 per person, so x is going to be the number of people at the party times 4x, plus $200. Okay, if the final charge for Dane's birthday party was $324, well, that means this 4x plus 200 would have to equal 324. And then how many people attended his birthday party? So we've taken these sentences and translated them to algebra. And now if we can solve this algebraic equation, we can answer the question. So let's solve for x, which is the number of people that attended the party. So the plus 200, let's subtract 200 from both sides. And 324 minus 200 would be 124 equals 4x, and the 200 minus 200 is gone. Now we only have one more step. We have to undo multiplication by 4. So let's divide both sides by 4. So on the right hand side here, the 4's would cancel out, leaving x equals, and how many times does 4 go into 124? Well, doesn't 4 go into 100, 25 times? And then 4 goes into 24 6 more times. All right, is that going to be 31? Well, let's see. Yep, 31, there it is. And again, if you're not sure, all right, double check on your calculator. And that's 31 what? That's 31 people attended the party. 31 people. All right. More ready. Indicate if the following statements are true or false. Explain your thinking. So we're going to have a true or a false and an explanation. Number 3, the notation 12 is less than x means the same thing as x is less than 12. It works just like 12 equals x and x equals 12. Well, you guys all agree if 12 equals x, then x would have to equal 12. Does that work with inequalities? Well, let's think about this a second. You know what I'd like to do? I'd like to graph each of these. So let's do a number line for the inequality 12 is less than x, and then another number line for the inequality x is less than 12. There we go. Now the key number on each of these number lines would be 12, hash mark, and there's the 12s right there. And here I have a less than, there is no equal sign. And over here I have a less than, no equal sign, so that means the dot on the hash mark for 12 would be an open dot on both of them. Now, when I read an inequality that has been solved for a variable, I like to read from the variable. It helps me immensely. So I'm going to read this, x is greater than 12. And wouldn't that be everything to the right of this 12? And then over here, I read from the variable again, which I typically read left to right anyway. X is less than 12. And that would be everything to the left. So was that a true statement? 12 is less than x means the same thing as x is less than 12. Look at our graphs. No, that's not. That's a false statement. And these two number lines, all right, and graphs of those inequalities is my explanation. Let's see, did I go on to 4 already? I did. Okay, number 4. The inequality -2 times the quantity x plus 10 is greater than or equal to 75 says the same thing as -2x minus 20 is greater than or equal to 75. So it looks like they manipulated the left-hand side of this inequality. Let's see if that works. So I can multiply by -2 on the left side without reversing the inequality symbol. Now that's a true statement, all right, because yes, if we multiply or divide by a negative number to solve an inequality, we do reverse the orientation of the inequality symbol, but that means we are multiplying or dividing both sides by a negative number. If we are just simplifying one side, it does not affect our inequality symbol. So let's take a look at this -2 times the quantity x plus 10. Well, let's distribute the -2 to the x, so that would be -2x. And then distribute the -2 to the positive 10, and that's going to be a -20, and then that is greater than or equal to 75. And that is the statement we have right here, -2x minus 20 is greater than or equal to 75. So that is a true statement. And again, the reason we did not reverse the inequality symbol is because we only multiplied by -2 on the left-hand side. We're just simplifying one side. I only reverse the inequality if I multiply or divide both sides by a negative. Okay, number 5. When solving the inequality 10x plus 22 is less than 2, the second step should say 10x is greater than negative 20 because I added negative 22 to both sides and I got a negative number on the right. Well, let's see if we agree with that statement. Okay. Oh, man, I thought I'd do a little bit of solving for you guys, but now take a look here. All right. The second step should say 10x is greater than negative 20. So they reversed the inequality symbol. All right. And did they have to do that? Because I subtracted negative 22 to both sides and I got a negative number on the right. Then let's look above. I only reverse the inequality if I multiply or divide both sides by a negative. Okay? This, we added a negative. That does not affect the inequality, so that's why this is a false statement. I only reverse the inequality if I multiply or divide both sides by a negative. Okay, adding or subtracting does not affect your inequality symbol, even if you are adding or subtracting a negative number. Okay, number 6. When solving the inequality negative 5x is greater than 45, the answer is x is less than or equal to negative 9 because I divided both sides of the inequality by a negative number. All right. So again, what they are saying here is they did negative 5x is greater than or equal to 45, and then to undo this multiplication by negative 5, they divided both sides by negative 5. And when you divide both sides of an inequality by a negative number, you have to reverse the orientation of your inequality symbol. So this greater than or equal to becomes a less than or equal to. And on the left, the negative 5's cancel, leaving x. And a positive over a negative is negative, and 5 goes into 45 9 times. So that's a negative 9. So x is less than or equal to negative 9. X is less than or equal to negative 9. We agree with that. That's a true statement. Why is it true? Again, if I multiply or divide both sides by a negative number, I reverse the inequality. And that's exactly what we did. We divided both sides by negative 5. The words that describe the inequality x is greater than or equal to 100 are, x is greater than or equal to 100. That's exactly what we just said. So they're just having you translate this inequality. X is greater than or equal to 100. X is greater than or equal to 100. Well, that's a true statement, and all we did was translate. Okay, now to the set. All right, we're just going to solve some inequalities, and then we're going to check to see if a given number is a solution. So solve for x, show your work, indicate if the given value of x is an element of the solution set. All right, very cool. So if we're going to isolate this x, the first thing I would do is get rid of this minus 9 by adding 9 to both sides. And addition does not affect an inequality symbol, so less than. And 2x, and the minus 9 plus 9 cancels, is less than. 3 plus 9 would be 12. And now we have one more step. Let's undo multiplication by 2 by dividing both sides by 2. And we just divided by a positive number, so the inequality is not affected. And the 2's cancel over here on the left, leaving x is less than 12 divided by 2, and 12 divided by 2 is 6. So if x is less than 6, would x equal 6 work? No, because we just said x has to be less than 6. So that's a no right there. Oh, and let's put it on a number line so we can definitely see this. And this is a great thing of practicing graphing our solutions. So on my number line, hash mark, and the key number is 6. And with a less than, I'm going to put an open dot on the 6. X is less than 6. So let's go arrow to the left. All right, and this is the set of solutions to the given inequality. 2x minus 9 is less than 3. X cannot equal 6, so that's a no. All right, I like graphing that too. Great practice. All right, so next one, 4x plus 25 is greater than 13. Well, let's undo the adding 25 by subtracting 25. Greater than, and then 4x plus 25 minus 25 cancels, and on the right I have 13 minus 25, which is a negative 12. And now we're going to divide both sides by 4 to undo the multiplication by 4. And we multiply by a positive, so that's not going to affect our inequality symbol. Still greater than. And on the left, the 4's cancel, so we have x is greater than. A negative over a positive is negative. And 4 goes into 12 3 times, negative 3. Okay, let's graph this one too, just for practice. So the key number on this number line would be 3. And greater than, I have another open dot on the negative 3, I should have said. And now x is greater than negative 3, so that will be everything to the right. Now, is this value part of the solution set? X equals negative 5. Well, x equals negative 5 would be over here. See, negative 3, negative 4, negative 5. That's not a part of the solution set. So again, the answer is no. Same stuff. More of this. This is good. All right, if we're going to solve for this x, we have to undo this subtraction by 4. So let's add 4. Bring down the inequality, and 6x minus 4 plus 4 cancels. Excuse me. And negative 28 plus 4 would be negative 24. And now we're going to divide both sides by 6. Does not affect our inequality symbol. So, and on the left, the 6's cancel, leaving the x. And on the right again, a negative over a positive is negative, and 6 goes into 24 4 times. So that's going to be a negative 4. So let's graph it. Hash mark, and what's the key number on my number line? Negative 4. What's the dot? Do you see the equals? That's a solid dot. And x is less than or equal to negative 4, so that's going to be everything to the left, including the negative 4 this time, based upon the solid dot and the less than or equal to. So now I look at their possible solution. X equals negative 10. Well, negative 10 is over here, and that would be part of this solution set. So we have a yes. All right, number 11. Well, see that minus 5? Let's add 5 to both sides. Bring down the greater than or equal to. And we have 3x is greater than or equal to. Oh, and look at this. Negative 5 plus 5, that's a 0. So let's divide both sides by 3. Does not affect the inequality, greater than or equal to. And now on the left, the 3's cancel, leaving x is greater than or equal to. 0 divided by 3 is 0. So let's graph it. So we have a hash mark, and our key number on this number line would be the 0, greater than or equal to, solid dot, and greater than means we'd go to the right. Okay, now x equals 1. Is that part of the solution set? Well, 1 would be right here, and yes, that would be part of the solution set. The graph really makes this easy. All right, solve each inequality and graph the solution on the number line. So we were just doing this before. Now we're just solving and graphing. So on number 12, let's undo plus 9 by subtracting 9 from both sides. Does not affect the inequality, less than or equal to. And x plus 9 minus 9, cancel. X is less than or equal to 7 minus 9 would be a negative 2. So I go over to my number line and 0, let me see, negative 1, that would be right there. I'm going to put a negative 2 right there. Now what kind of dot? Do you see the equal sign? That has to be a solid dot. And then I read my inequality from the variable. X is less than or equal to negative 2. That would be everything to the left, including the negative 2, the solid dot. Okay, number 13. Well, let's start by adding 4. I hope you're noticing we always get rid of this addition or subtraction first on these two-step equations. And then let's bring down the greater than. And negative 3x, the minus 4 plus 4 canceled. And then 2 plus 4 on the right is 6. And now let's divide both sides by negative 3. Now, here we divided both sides by a negative, so do you see this greater than? I'm going to have to reverse that inequality symbol and make it a less than. And then the negative 3's cancel on the left, leaving my factor of x. So x is less than, and here we have a positive over a negative is negative, and 3 goes into 6 2 times, so that's negative 2. So let's find negative 2. Hey, negative 2 again, right there. And x is less than negative 2. Well, above this was x is less than or equal to negative 2, solid dot, less than negative 2, open dot. And there you have it. Okay, number 14, one-step equation. 3 times x is less than negative 6. Let's undo the multiplication by 3 by dividing both sides by 3. And we divided by a positive, does not affect our inequality. The 3's cancel on the left, leaving my factor of x. And a negative over a positive is negative, and 3 goes into 6 twice. So that's a negative 2 again. X is less than negative 2. Well, we'll have the same graph we had above. Negative 2, less than, that's an open dot, and everything to the left. Wow. All right, number 15. Ooh. Well, if I'm going to isolate this x is being divided by 5. So how about we just multiply both sides by 5? And that will not affect our inequality. And on the left, these 5's cancel, leaving the factor x is greater than. Now, let's see if we can do this without a calculator. All right. Do you all agree that, see that 5? Doesn't 5 go into 10 twice? So I cancel the 5 and the 10 becomes a 2, and I see negative 3 over 2. So x is greater than negative 3 over 2. So that's negative. Here you might, if you say that negative 1.5, you may see that better. So let's go negative 1.5, about right there. Yeah, that's what I did. Greater than, so I'm going to put an open dot where negative 1.5 would be approximately. And x is greater than that negative 3/2, so my arrow would go to the right. Oh, these are great problems. All right, number 16. Solve each inequality and graph the solution of the number line. So same stuff. So here we're going to have to undo multiplication by negative 10 by dividing both sides by negative 10. And you know, we just divided both sides by a negative number, so this greater than now becomes less than. And on the left, the negative 10's cancel, leaving the factor of x. And on the right, we have a positive over a negative, which is negative, and 10 goes into 150 15 times. So that's negative 15. X is less than negative 15. Negative 15, there it is. Less than, that would be open dot. And if x is less than negative 15, that's everything to the left. 17. X divided by negative 7. So we're going to need to multiply both sides by negative 7. All right, and we multiplied both sides by a negative number, so see that greater than or equal to? Less than or equal to. And on the left, the negative 7's will cancel, leaving your factor of x. And on the right, we have a negative times a negative is positive, and 5 times 7, 35. So x is less than or equal to 35. Where's my 35? 30, 31, 32, 33, 34, 35. I think it's right there. And less than or equal to, that's a solid dot. Less than, everything to the left. There you have it. Wow, right on. Okay, now solve each multi-step inequality. Okay, so we had one-step multiple inequalities here. Now we're going to go multi-step. And you know what? Let's graph them too, because that really gives us a good visual of our solution set. So, oh, I see. Yeah, there's x's on both sides. So, do we want to subtract x or subtract 2x? Because the first thing we want to do is get our x's on the same side. I'm going to subtract the x to keep my number of x's positive. Makes it a little easier. You could do it either way, though, honestly. Now, because we subtracted, does not affect our inequality. and x minus x cancels, leaving the negative 5. And on the right, 2x minus x would give me 1x, or just x, and we still have that plus 3. So now we have to subtract the 3. And that will not affect the inequality, so still greater than. Negative 5 minus 3 more, negative 8. And then we have x, and the plus 3 minus 3 cancels. So x is less than negative 8. Do you notice how I read that from the variable too? That makes it so much easier for me to graph. Hash mark, key number, negative 8, less than, that's an open dot on negative 8, and x is less than negative 8, so we're going to the left. And that is why I always read from the variable. Some people will see this negative 8 greater than x, and they see greater than, and they go right, even though this is x is less than negative 8. All right, number 19. Okay, well, there's different ways we could go about this, and wow, you know, we've got, so what, I wonder what I did for the first step, because there's so many different ways we could do this. All right, I probably did 3 would go into 12 4 times. I bet you I just simplified this fraction 3 over 12. I did, look at that. Okay, so let's bring down the less than or equal to, because we're just manipulating the left-hand side here, and 3 goes into 12 4 times, so that will leave my x minus 4 up top and a 4 in my divisor. All right, now let's see. Well, this is a proportion with x's all over the place. This is a pretty advanced problem right here. Could we just cross multiply to solve this proportional inequality? Oh, there we go. So, and again, I'm multiplying by 4 on this side and by 3 on this side, so they're all positive. That won't affect my inequality symbol. And now, let's think about this. 3 times x minus 4. Well, let's distribute the 3 to the x. That would be 3 x's. If I did that side first, I did. And then 3 times the negative 4 would be minus 12. And on the right, I have 4 times the 2x. That would be 8 x's. Now let's get our x's on the same side. So I would subtract the 3 x's. Does not affect my inequality again. So now 3x minus 3x cancels, leaving negative 12. And 8x minus 3x is 5x. All right, now let's divide both sides by the 5 to undo that multiplication by 5. And so let's see. Negative 12 divided by 5, I can't simplify that. Negative 12 fifths. And over here on the right, my 5's cancel, leaving my factor of x. So I'm going to say x is greater than or equal to negative 12 fifths. And again, notice I read from the variable. So key number, negative 12 fifths. There's an equals there, so I need a solid dot. And x is greater than or equal to that negative 12 fifths, so that would be everything to the right. All right, number 20. Now this is one of those problems where I think I'm going to simplify the left-hand side first. Yeah, so let's just distribute this 2. Now, I could have divided everything by 2, but then I'd have fractions, and you know what? This is probably going to make this easier. So we'll go 2 times the x, 2x, and 2 times the negative 3, negative 6. So 2x minus 6 is less than or equal to 3x minus 2. Now, let's subtract 2x from both sides. Does not affect the inequality. 2x minus 2x is gone, so I have a negative 6. And 3x minus 2x is x, and we still have that minus 2. Now let's add 2 to both sides. Does not affect the inequality. So negative 6 plus 2 is negative 4. And x, and the minus 2 plus 2 cancels. So x is greater than or equal to negative 4. Key number, negative 4. Less than or equal to, if I read from that, so I'm just looking at the equal right now, solid dot, but now I'm going to read from the variable. X is greater than or equal to negative 4. So that'd be everything to the right. Wow, this is fun. All right. Topic, using substitution to solve linear systems. Now, the Go section, they're trying to get you to discover some things here, all right? So this is using substitution, and they expect you to struggle with these a little bit and maybe Google substitution and see what you can come up with. These are not supposed to be easy because we haven't talked about this, but this is where we're going to be going down the road. So solve each system of equations by using substitution. All right, well, look at number 21. This is a system, and these are all linear, so we're just looking, if we graph these lines, where would they intersect? What's the ordered pair? So y equals 5. So if y equals 5, can I put a 5 in the lower equation for that y? Yeah, so negative x plus what's y? 5 equals 1. And now we can solve for x, so let's subtract 5 from both sides. Equals, and now we have negative x, and the plus 5 minus 5 is canceled, and on the right we have 1 minus 5 is negative 4. Now if negative x equals negative 4, doesn't that imply x would have to equal positive 4? I like to do those like that. If negative x equals negative 4, that implies x would have to equal 4. And some people like to think of that as multiplying or dividing both sides by a negative number. You can do it that way too. All right, now we have the x-coordinate of the point of intersection of these two lines. So x is 4. And what is y? Well, they already told us. Y is 5. So that point, that ordered pair 4, 5 is the point where the horizontal line y equals 5 and the oblique line negative x plus y equals 1 would intersect. And that's substitution. Now, on number 22, now they're telling us x is 8. So see the equation below? See that x? Let's just make that an 8 now. So 5 times 8 plus 2y equals 0. Now we'll solve this for y. So let's see. 5 times 8 would be 40 plus 2y equals 0. Now subtract the 40. So we have 2y equals negative 40. And then we would have to divide both sides by 2. 2's cancel on the left, so we get y equals, and a negative over a positive is negative. 2 goes into 40 20 times, negative 20. So now we have a y-coordinate of negative 20. And what's our x-coordinate? Well, they told us x equals 8. So this is the point where these two lines, this vertical line and this oblique line, would intersect. I promise. This is cool. Uh-oh. Now, we better solve for y first. See the 2y equals 10? Well, if 2 times y equals 10, 2 times what number is 10? Wouldn't y have to be 5? So now we can just do our substitution, make this y right here a 5. So I'm going to go 4x minus, and 2 times 5 is 10. I bet you I just put a 10 there. I did. All right, now let's solve for the x. So let's add 10 to both sides. Equals, and now we have 4x, and the minus 10 plus 10 cancel. And on the right of that equals, we have the 50 plus the 10 is 60. And now you guys are going to divide both sides by 4. All right, equals. And on the left, the 4's cancel, leaving the factor of x. And how many times does 4 go into 60? Wouldn't that be 15? I think so. So x equals 15. And now we have our x-coordinate is 15. And remember when we said y has to equal 5? Y is 5. Okay, so 15, 5 is the ordered pair where the horizontal line 2y equals 10 intersects with the oblique line 4x minus 2y equals 50. 24. Oh, 3 times x is 12. Let's solve that for x. So 3 times what number is 12? Wouldn't that be 4? So now we can just make this x down here a 4. So 4 times 4 is 16. 16 minus y equals 5. So, my friends, let's solve for this y. So let's get rid of this 16, and that's a positive 16. So let's subtract 16 from both sides. And now we have negative y, because the 16's canceled, equals 5 minus 16. Well, that'd be negative 11. Oh, and this is like up here. If the opposite of y equals negative 11, then y would have to equal positive 11. So now we have our y coordinate of 11. And what did we decide x would have to equal from the first equation? X has to equal 4. And this is the point where these two lines, one vertical and one oblique, intersect. Now 25, we have two oblique lines, one with a slope of 2 and one with a slope of 1. Where do they intersect? Well, if y equals 2x minus 5 and y equals x plus 8, doesn't that imply that 2x minus 5 would have to equal x plus 8? And now we can take this and solve for x, so I would subtract x from both sides. Bring down the equals. I wrote it over here, but 2x minus x is x minus 5. And on the right, x minus x is gone, and I'm left with the 8. Now let's add 5. So x minus 5 plus 5 would be x, and 8 plus 5 is 13. Okay, so the x coordinate is 13. Now, what are we going to do? We're going to have to substitute this into one of the equations to get our y. I would probably use this one right here. Doesn't y have to equal x plus 8 or 13 plus 8? That's a 21. Yeah, there it is, 21. So the ordered pair 13, 21 would give the point where these two oblique lines intersect. Now one more, and I think this is it, and it's a good thing because I have another class starting. So 3x equals 9. 3 times what number is 9? Isn't it 3 times 3, 9? So wouldn't x have to be a 3? All right, and let's substitute now. So see that 5 times x? Well, x is 3. 5 times 3 is 15. So 15 plus y is negative 5. Solve for the y now, so let's subtract the 15. Bring down the equals, and we have 15 minus 15 cancels, and we have a y equals negative 20. So there's my y coordinate right there. Now, what did we already say x had to be? 3. So the ordered pair 3, negative 20 is where this vertical line and this oblique line would intersect on the plane. And that is our Ready, Set, Go. I think this has been the best Ready, Set, Go of the year, and that is why I wanted to create this video. And I'm going to talk to you guys next time we get together about a lot of these problems. Everybody have a wonderful day.